demonstration. So let me sort of jump straight into this and sort of say that what you're about to see is not just talk from us and slides. In fact, I will do a quick camera change and just show you that in fact we do sense it all in front of us. And very quickly, or very soon rather, you're going to see that we're going to do a live demonstration. So my colleague is going to have a sensor in the Sense It All platform. We have this LED app. This app is part of what we call a Sense It All app. This app, or this phone rather, is in Bluetooth connection with this meter. And you're going to see my colleague put some samples onto this onto the sensor and actually make a recording of the lead concentration in that particular sample. Now, that particular sample is actually quite a clean sample. I just want to give you a sense of the power of electrochemistry, that neither of these samples I would describe, they're both liquid, particularly transparent or even particularly clean or particularly clean from particulates. But that is the power of electrochemistry as a science, that you can test less than ideal samples with it. With that said, let me go back to actually sharing my screen. So we are going to do some, let's say, real testing in a minute. So I want you to kind of know that this is not all just going to be all talk. So the platform that we have in front of us is the Sense It All platform. It's driven by apps on a smart device, and I'll talk about that as well. And it's really good for doing rapid detection. Now, what you're about to see is Solrun will be taking the meter. We'll have one of our sensors in that meter, and then we'll prepare a sample, and you'll see Solrun do a kind of what we call a 1 in 5 dilution. That will be sort of 1 volume of the sample and 4 volumes of a buffer. That really helps control the sample type. Otherwise, you could imagine that industrial water, wastewater, drinking water, soil extraction, these will all have very different compositions, but by doing a 1 + 4, which is a 1 in 5 dilution, we control all of those variables. You'll see Solrun will use the app. The app will be in Bluetooth connection with the meter. The app will tell the meter what to do. The meter will do its analysis. Whilst it's doing the assay, Solrun will actually hand back to me. But when at the end of the assay, the meter will give the raw signal to the app, and the app will actually upload that to a cloud system called Julie, where it will go through a series of steps. We'll do pre-processing, we will do processing, and then we will do information extraction. Information extraction is basically taking the raw signal, putting it through a calibration algorithm, and sending back the concentration of the sample. So if you're the kind of user that just needs a result and you don't want to be engaged, with this, let's say the deep science on this, you absolutely can just have the result on your phone, and we will demonstrate that. But of course, if you're like a quality manager or you're remote from those testers, you can go in, you can see the value, and you can see the signal behind the value. You can see who did the work, you can see what the time that you did it, and you can see the date that you did it. So it's got some amazing traceability regarding this. So many point of need devices, you get this result, but there's no real, the ability to do quality control in real time on that and actually see what the raw signal looks like. It's just not in the device, but this is based, it's a meter, an app, and a cloud system that all work, let's say, together. So what I'm going to do now is I'm going to mute myself, stop sharing, turn off my camera. Solrun's going to introduce herself and do your quick demonstration.
Hi, so yeah, my name is Solrun, and I will run a quick test that Martin is talking about. So yeah, I will show a close-up view of our system today. So here is the SIA device, and our phone with the app, and here you can see a close-up view of the sensor cartridge. So a sensor cartridge is placed in the device, and we will pipette our sample onto there. But first, I will just click on test settings, where I have written my ID and also called this sample for Lead Tuesday. So I will click continue, where I get a screen with instructions. So here you can see that the first thing I need to do is mix and prepare my sample. So Martin was saying that we are making a solution with 4 parts of a lead buffer and 1 part of our sample. So that's what we're going to do. So we have an empty vial here, and we will add 200 microliters of the buffer, just like this. 200 microliters. And in order for us to obtain a 1:5 mixture ratio, we need to add 50 microliter of the lead sample. So here's our vial, and here we have 50 microliter, just like that. Making sure that we can test a variety of different samples with different compositions, just like Martin mentioned. So my sample just needs to be mixed. So I'm just using a vortex just to quickly mix my sample and make it as homogeneous as possible. So I will go back to our close-up view of the system. And our app tells us to apply 50 microliter of the sample onto the sensor. So that's what we will do. I'll remove the app for now, and then I will add 50 microliter onto the sensing area, just like this. Covering all the electrodes of the sensor. So just like that. And then I will click Start Measurements. So now it's starting to deposit lead on the sensor. So we'll go back to Martin while we wait those 240 seconds for that to finish.
Great. Okay, thanks very much, Solrun. So what I'm going to do is I'm just going to describe the science now of, or in part, the science of what we're actually up to. So I say here, what did you see? It's really, what are you seeing, I should say, really. So you saw Solrun take the sample of lead. You saw her prepare essentially a sample by taking the raw sample and adding 4 volumes of buffer. So it was basically what we call a sort of 1 in 5 dilution. Don't worry, the software actually takes care of that because it knows that's what you're doing. Now, the reason we do that is because it allows us to be broadly applicable. So you can appreciate that we really dominate that sample. It's only, so it doesn't matter so much if it's wastewater, well water, drinking water, some sort of soil extraction, etc. Now, what is happening at this moment is that we're actually enriching the sample onto the electrode. So rather than having all this lead kind of in the solution, we're actually bringing it down to our sensor and essentially enriching it or increasing the quality of our signal. And then what the instrument will do is it will actually oxidize the lead from that electrode. And in doing so, we get a current. And if we integrate current, we get a charge. And charge tells us literally how many molecules of lead actually were on that particular electrode. So that's what the Sensi-All meter is doing at this moment in time. Now, Solron was using the Sensi-All app. Now, this app is, just to show you the maturity of this technology, this app is actually available on the Google Play Store. You can scan this QR code and you'll find that if you've got an Android, that is, and it will take you to the Google Play Store. If you're on an iPhone or an iOS operating system, you can scan this QR code and this will take you to the Apple App Store. So just to appreciate that, we have deployed these apps. Now, there's something very powerful about the Sensi-All platform. The Sensi-All platform, so we are specifically this afternoon doing a analysis of a lead sample, but this is a very functional instrument that is used by the research community for developing new assays. But by combining this R&D functionality with what we call a data pipe, so the data will be gathered by the instrument, it'll go to the cloud, it'll come back to the instrument, and we'll come back with a concentration, in this particular case, of lead in ppm. But we have all of these so far deployed different analytes. So the capsaicin in chili, the gingerol in ginger, pH, nitrate, total antioxidative capacity, glucose, potassium, testosterone, NADCC, which is a sort of a source of free chlorine for water sterilization, and then lead itself. We do have a bit of a roadmap for this. So at this very moment in time, we're focusing on lead, but just to understand that actually the other, let's say, heavy metals are also available to us. So if you're interested in those, then we would like it if you would actually contact us and basically tell us. Now, what I'm going to do is I'm just going to stop sharing my screen, and I'm going to mute my mic for a second and just, sorry, and just let Solron come in.
Yeah. So as you can see now, it's closing in on finishing those 240 seconds of deposition, where Martin was saying that lead is that lead ions is being deposited onto the sensor, and then you will see that it starts this new measurement, the stripping measurements, where it's actually assessing just how much lead we deposited onto the sensor. So now the data is being analyzed, and the data is also being uploaded to Julie, the cloud, where you can see all your data. So I will show you that when we get the results back. So first off, you will see the results on the screen of your phone, which is just a simplified view where you just get your numbers. But then if you want to see what is behind those numbers, you'll go in and see the raw data. So that's a strength that this system has, because you can also check what is actually happening if something is going wrong. So here you see that it comes back with a concentration of 362 ppm on the phone screen. So what we will do next is actually go to Julie. So I will just need to click refresh. And then you see Lead Tuesday, which was what I named this sample in particular. So here you can see the deposition data, and further down you can see our lead sample and those peaks that Martin was talking about. And if you would have a different heavy metal, it would be someplace else. And you can also find operator ID for me, and then date and time to go back to your data later in time. So back to you, Martin.
Okay, cool. Well, thank you for doing that demonstration. So what I will do is just say thank you for basically watching our demonstration this afternoon. This was done without any kind of editing. Just Solron did that live, and I was also chatting live as well. So if you've got any questions regarding the detection of lead in complex samples and the quick, and I would describe this as quick and easy, and definitely quicker and easier than necessarily collecting a sample, sending a sample to a lab, waiting some time for the result to come back. So I hope that was useful to you. And if you have any questions of ZP, please don't hesitate to reach out to us. Okay, thanks very much.